introduce you and to have present Dr. Matthew Winsor.
Thank you. I'm getting a little teary-eyed, I gotta admit. I didn't think I'd get that gushing review from Nick, because he was a former student of mine. That means I graded him. But yeah, I remember when Nick came in and said, I want to go to graduate school. I'm like, I hear Georgia's nice. I knew there were good people at Georgia, and so I aimed him this way. I figured if he's going to go big, right? If he's going to go to graduate school, he should go big. And he came here, so he did. So this is the title of my lovely talk, Integrating Knowledge of Secondary Mathematics Teacher Preparation, or SMTP as we're now abbreviating it. We've got an abbreviation officially for it now. It's very exciting. I did get a grant from the NSF to work on this project. Let's see if this works. Yes. So as I was sitting there thinking about what was I going, I'm coming to the hallowed halls of Georgia, and I'm reflecting on what I've done. I realized that I've been in the math ed field for 20 years, and then I was like, am I really that old? I don't feel that old. And so I just thought I'd give you a preview of where I've taught. I started at Crescent View Middle School, home of the Vikings. They're actually tearing that school down now and rebuilding it somewhere else. Didn't know that until just this week. Then I was at Oceanside High School, I was at Crescent View for a year, and then Oceanside for 4. And then West High School was in Iowa City. It's an interesting story because they came to I was doing my PhD in math ed, and they came to our department and said, we need a teacher that will teach for 2 periods, because I don't remember if the teacher broke her leg or there was an emergency, and I was like, call me. I'd rather teach 2 classes at a high school than work at the gas station I was working at. So I got to teach at West High School. And then my first job out of the University of Iowa was at UTEP, where I met Nick, a good place. I was there for 6 years, and now I'm currently down here at Illinois State University. And so it's kind of been a really interesting ride, because I started out at junior high, and now I'm preparing teachers, and I've been everywhere in between. And this is, I just thought, I have 5 kids. I like to blow people's minds. Are your minds blown yet? But these are my kids, and this is really, this is the reason that I'm passionate about teacher education, because my kids have to go to school and learn math, and I want my kids to do well in math. And what's interesting is Sabrina and Jeanette have both had former students of mine as teachers, which makes me super nervous. Makes me really nervous, and every so often they'll come home and say, Dad, the teacher this. I'm like, oh, okay, it's all right. They're why I'm passionate about what I do. I don't really want to bore you with 20 years of experience, because it's pretty boring. But I've realized that as I've progressed through the field of mathematics education, I've had experiences that have kind of led to what I'm doing right now, and kind of actually support this model of secondary math teacher preparation that we're trying to promote and move along. And so I'm going to try to give you just a really brief overview of some of the things that I've learned over the years, with respect to the literature. And I'm not an expert on this. I'm not an expert on any of this stuff. I don't feel like an expert. Maybe I will be someday, but never. I feel like I'm always learning, and I'm always growing. It was interesting to think about this process. But a lot of these things have contributed to what I'm doing right now. So here we go. Of course, at BYU, where I got my undergraduate education, my teaching degree, they introduced me to this 1989 curriculum and evaluation standards for school mathematics. And they came in the room one day and they went, ho, 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 because it was the NCTM standards, and we were going to live them righteously. And this was the Bible of all math teaching. And they taught me things like that problem solving is important and group work is essential. And you need to have real world problems, and don't you ever lecture. And my professor would always say, well, maybe a little. And then you're going to have incredible learning. Okay. So I went armed from BYU to my first teaching job, Crescent View Middle School, and I was going to do NCTM. I was bound and determined to do NCTM. And that's what I would say, I'm going to do NCTM. And what happened? I did it for a semester, and I burned out. I didn't know how students learned like this, even though I'd had a class. because one class is really all you need. I didn't know they had told me about pedagogy, but I'd never practiced it. They said, hey, you should have group work. I said, I'm gonna have group work, and I go into my classroom, I put kids together. I didn't know what to do with them. And not a whole lot of incredible learning was going on, and I was actually becoming sick and losing hair. It was a mess, and so after a semester, I threw it out the window, and I taught traditionally. And I made it through made it through the rest of the year. Almost quit math teaching. That's for the trivia quiz at the end. I almost quit teaching after this year because I had such a hard time because I felt like I was a failure because I didn't do NCTM. But I like it. So after I taught for 1 year, I went and my principal said, you should really go get a graduate degree because you're not going to get paid very much if you just have a bachelor's degree. That was his whole reason. And maybe he just wanted to get me out of there. I don't know. Maybe he'd seen my teaching and went, no, this whole group work stuff's really not working. You're just so noisy. So I went to UC San Diego, and they had a program where you could teach during the day and go to school at night. And it was supposed to be from summer to summer, and you were going to do some an action learning research project. Action research. And so I learned about this guy, Vygotsky, and this idea of zone of proximal development, and Pat, you talked about it yesterday, it was so awesome. It's like, yay, is EPD still around? And because I hadn't thought about it, it's in my heart, but I haven't specifically talked about it for a while. But this idea of helping the student go from what they can do by themselves to what they can do with the knowledgeable other was very powerful for me at the time, and it kind of said, well, that's maybe why the reason group work could be good if you did it right. And then Wirtz talks about intersubjectivity, which for me at the time I understood these people need to kind of be all on the same page, and because they're negotiating via language. And so they need to have the same definitions, they need to talk the same language. And I thought that's important. We should all be, we need to establish a way to communicate so that we can then operate within the zone of proximal development. So that was UC San Diego. I graduated, went out, taught some high school. I lost my mind after 4 years of teaching high school and with my master's degree. I lost my mind and said, I need a PhD. I really enjoyed doing action research in my classroom. I realized that research is a way to empower yourself to make change. I love that. I thought I could help other people be awesome math teachers. I can do research. I like this stuff. So I lost my mind and went to get a PhD. I went to University of Iowa, worked with Doug Grouse, my good friend. And so then we started learning here. And one of the first seminars we had for graduate school, we read Lippi and Moe. Anyone seen it? Read it? Of course, I hope so. And we loved Puffin, Profound Understanding of Fundamental Mathematics. In fact, we even had a Mr. Puffin man that would go on the board when we'd have our seminar because we loved it so much. But this idea, there's two things. One, there's this idea of understanding mathematics well so that you could teach. It's more than just, I know math, I can do math. You have to really understand it well and have this connectedness. You have to see math from different perspectives. You need to know how it all works together and how it works vertically and how it works horizontally. And I love this. And then there's the part in this book that said, and Americans don't do that at all. And I was like, wait, I'm an American. I do not stand for that. I was so frustrated because everything she was saying, I was like, this is awesome stuff. And it was really ringing true to me. And at the same time, I'm an American. How come we're not doing that well? So I got interested in teacher knowledge. That really became a focus for me, and which was good because Dr. Grouse was interested in it too. So then I found Dr. Beagle's article from 1972 where he did a study and he was looking at teaching algebra and what math classes you've taken. And he says, well, if the teacher understands modern algebra, my favorite type of algebra of all times, okay? I don't know if you know what that means. It says it has no significant correlation with student achievement in algebraic computation or the understanding of 9th grade algebra. And I'm going, why the heck did I take that class? But I'm going, wait a second here. Good math teacher needs to know a lot of math. That shook me a little. It shook me. It was good to shake me. I need to be shaken. but I didn't sleep that night. But then we come to the second finding, teacher understanding of algebra, real number system, has no significant correlation with student achievement in algebraic computation, but it does have a positive correlation with student achievement in understanding algebra. So I'm like, oh, okay, now there's something there. There's something there. So I'm getting into my journey of this teacher knowledge, and I'm going in and I'm thinking about it, and the next person I met, oh wait, this was an interesting point. I'm sorry, I forgot that. This is an interesting point. It says there may be a cutoff such that the increase in teacher understanding above this cutoff point do not lead to increased student achievement. And it was interesting that I had known teachers who were exceptionally gifted mathematically, but had no teaching ability whatsoever. They were very smart, but the kids weren't learning things from them, and I didn't know what was going on. It just didn't make any sense to me. And I even see student teachers that way still at ISU. They're brilliant at math. They're gifted at math. I'm jealous of them that they are so smart. But they have a really hard time teaching and conveying the mathematics to the students. So something else needs to be going on. So then Schulman came along in my life and had in Iowa. And he identified types of teacher knowledge. Now, these aren't all of them, but these are the ones that caught my eye. I was really excited. I was like, oh, now we're starting to put the puzzle together. And so we need content knowledge, we need pedagogical knowledge, we need knowledge of learners, and then we need this thing called PCK, and I'm pretty sure somewhere in the math world someone has a tattoo that says PCK on it, because this has been a really exciting topic. PCK, and I don't know, in master's or PhD students, you know when you have that moment of clarity, when you know what you want to do for your dissertation? I thought I had that moment of clarity. I said, I will understand PCK. I will show how to teach PCK. And then Dr. Grouse and I had many, many conferences where Dr. Grouse said, no, you won't. I said, but yes, I will. I can do this. And no, you won't. And being the fact that Doug is more stubborn than I am, only a little bit, but more enough, and plus he held my life in his powerful hands, I gave in. But this still, it fascinated me as now we're identifying types of knowledges. And this one, in fact, in my dissertation, I even used this analogy. My wife was so proud that I used it. She likes it, so she said, share the analogy with them, they'll like it. This one, in my little mind, seemed like this was a stool, and it had 3 legs. And these were the 3 legs to this stool, and they were held up by this stool. And if we took out one of these 3 legs, the stool doesn't stand. She was so proud of that analogy, but I still kind of feel that way, that these teachers need all these 3, and they need them to work together. They need them to work together to be a successful teacher. Now, as I've continued my journey with teacher knowledge, Dr. Ball came along with the egg. And the egg is I think, I appreciate the egg because it does a couple of things for us. It says, hey, math teachers have a special type of math knowledge they need to know. And I've always thought that we need to know how to be able to take math and deconstruct it and lay it out so that the kiddos can see all the parts. It's almost like a mechanic. We've got to be able to take the engine apart so that we can see each part and how it works, and then we've got to be able to put the engine back together to see how it works together. And so I love that, hey, we need some specialized content knowledge. But also I'm seeing, here's this PCK again, and we've got this knowledge of content and students, it's KCS, and knowledge of content teaching, KCT. Again, we're taking knowledge and we're kind of putting it together. And I'm thinking, how do we get our students to put this together? And it became even more important to me as I went to ISU, and they said, hi, Dr. Winsor, you're teaching methods, our senior year methods course. Good luck. I said, do you have a book? No, good luck, have fun. Okay, and there was a lot of support. My colleagues don't leave us hanging, but there was a lot of support, but I felt very much, I need to know how to help my students put this knowledge together, because I don't know how, and everything I read says, there is this type of knowledge, but I've not seen things that are helping me as a methods course teacher, activities that I can use to take that knowledge and put it together and to use it. And Dr. Ball even says, that we take the subject matter and the pedagogy and we teach them in different spots. Now, as I've been here, I see that you don't do that here. And it's been awesome to watch. Honestly, I've really enjoyed being in the classes that I've seen. But I know, I'll just speak for myself. In my undergraduate, I did education over here. I did math over here. The math folks really didn't like the education folks because that was all fluffy stuff. And I think the education folks talked to the math folks, but there was this divide. And so it's very real. There's this divide. How are we going to get our students, our pre-service teachers, to take this from over here and this from over here and put it together? Where's the bridge that's going to help them connect it? So my colleague, David Barker, really, I know him to death. Well, you can imagine I know a lot of people to death. I'm kind of that way. I'm a little obnoxious, but I try to keep it controlled. I've been asking, where is the verb in all of this? Where is the verb? Because if you look at PCK, if you look at Dr. Ball's model, they're good models, but they're identifying. Face value, they're identifying, this is this type of knowledge, this is this type of knowledge, we're giving it names. And I like those names, and I want to help my students create that knowledge, but I need the verb. I need to know, how do we create this knowledge? So I thought, well, teaching's a lot like problem solving, and I came across this book by Marshall, and so I'm going to read. I read a little bit about schema theory, and I still don't have my head all the way around it, because that's a lot. But I like to continue to learn, so I'm grappling with it. This idea of a schema is a vehicle of memory, line, organization of an individual's experiences. So in a nutshell, it's kind of how the brain takes in these experiences and organizes them and uses them and can connect them and recognizes when something else happens as a similar type of thing as what we have here. Can make plans, can use procedures, can access skills. It's this idea of this engine that helps organize our memory. And this part here kind of caught my eye. We've got networks of connected bits of knowledge called elements. And I thought to myself, when students go to a methods course, they get little bits of pedagogy that they learn. And if they go to a geometry course, they're going to get little bits of geometry. And an ed psych course, they're going to get little bits of how do students learn. And so that kind of rang true. And if we have these more connections in the schema, the stronger it is. And also that schema can be connected, so if one fires up, another one will fire up too. And again, I'm sitting here, I'm chewing on it, and this is kind of what we have come up with. And this is a model to help me kind of just see what's going on. I like geometry because I can see it, and I needed to see what's going on. So in my mind, this is what's happening in a teacher's mind. I am not an educational psychologist. I do not do brain research. This is just a model to help me think about what's going on so that I can try to plan activities to help these students connect these bits of knowledge. So they have these bits of knowledge, I have M for math, CI for curriculum instruction, L for learners. Perhaps there's a bit of them that are connected in a certain way. The teacher makes some decisions because of the classroom, and as I've looked at this, I thought maybe I should take the classroom and put it all the way around the brain, but it doesn't matter really for right now. So then we have things happen in the classroom, and they reflect, and as they reflect, perhaps they're making new connections. When I did this, my students reacted this way. And so there's this, that might be a connection between a CI and an L that's newly formed because they did something and the students reacted a certain way. And we might have it connected to an M because I did this while I was teaching slope. And so this is really our effort to kind of draw a picture, just to kind of help us get our head around what we think is going on. Now, we're not trying to classify knowledge. I would argue that given the connections, we can connect the connections back to Dr. Ball's model or even to PCK. We're trying to see the verb, what's happening, what's going on. So that's our model of what's happening in the brain with their knowledge. And then two quotes kind of drive what we're trying to do with our project. One is by Bishop: if I can discover how teachers go about making decisions, then I shall understand better how teachers are able to teach. So what we're trying to do with our project is to discover, and it's tough, I'm not gonna lie, but to discover how our pre-service teachers are using their bits of knowledge through a decision-making process. We're trying to see what's happening. And then also through this process of reflection, teachers transform their inner knowledge into active classroom practice that continually evolves as they encounter new situations. And so based on this quote, we want our pre-service teachers to be reflecting, which means they need to be having experiences that they can reflect on. So, I'm gonna breathe for a second. Whew. Okay. So I've got to give you a definition, because we say integrated knowledge, and this is just our working definition. And this is for pre-service teachers. This is not for your in-service teachers. This is just for our pre-service teachers. When we talk about knowledge integration, we're giving them an opportunity for pre-service teachers to use their different knowledge types in tandem to address this teaching situation. We don't know if they do it, but we're trying to set the conditions with the task, with the question, whatever we're doing, so that our pre-service teachers can go into their brain, grab the bits they need to address the situation. And so, how should we prepare our teachers to develop this integrated knowledge that they need? So in our program, we're really trying to make knowledge integration a goal, and I'm going to show you how. We are trying to make sure that our pre-service teachers are having more opportunities to make decisions and then reflect on what they're doing. And then this bottom one, we really want to give our pre-service teachers as many opportunities as possible to practice using this knowledge or applying this knowledge in real settings. So we're trying to get them out in the classroom to do this stuff. And so, what are we doing? I don't know. This is what we're doing. And by the way, graduate students, if you want to get a grant, come up with a really awesome acronym. My acronym is BRAIN MAP for instruction. Bam! Isn't that awesome? No, it's fine. That took me 20 minutes. I was sitting there 20 minutes. BRAIN MAP for instruction. But what's happening here? This is kind of the model for, this is our kind of our foundation for our model of secondary math teacher preparation. And there's no real starting point in this, but it's kind of a cyclic thing where, let's say we start something in math. Okay, we'll just start in math. It's easy, it's the closest to me. So we start examining a topic in math. Let's just say complex numbers for discussion's sake. We're going to do some college math, which means we're going to get down to the fundamentals of complex numbers. We're going to connect it maybe to their complex analysis course or other courses they've taken so that they won't complain when that course. I said that way too much as an undergraduate. I feel guilty every time I think about it. Then we also try to connect it in the math course to school. So what does this all mean for school mathematics? How would a student think about this? So again, taking the math, thinking about it from an advanced standpoint, trying to connect it to school. Now, we might shoot it from there over to here to the pedagogy class. In the pedagogy class, we may have some readings on a certain topic. It may be questioning, but as we talk about questioning, we may be using complex numbers as our topic to use as an example. We have students develop classroom materials. Then we have them go and try it out in their clinical experience. And then obviously reflect, and in this reflection also includes coming back and reporting out to everybody. So this is a lovely flow chart, but how does it work? What are the nuts and bolts at ISU? At ISU, we use the model, the brain map model, in our secondary teaching methods course and our capstone course. Now, let me just put this into perspective. Our students, they take 3 methods courses. There's an introductory one early on in their career to make sure that they know they really want to be a math teacher and introduce them to some of the aspects of NCTM and Common Core and those sorts of things. Then their senior year, fall semester, they have a second methods course. This is the methods course that I'm talking about right here. And they take a capstone course. And I'm going to talk a little bit about those courses in detail in just a second. And then tied to the methods course is a clinical experience. Our clinical experience is 5 days a week, an hour each day. So they basically go to the same class every day for a week, for 14 weeks. So they're in the classroom for an hour a day, which is nice because we can take things from either class. We can either take something here and bring it down into the capstone course. So, hey, we studied this in the clinical. Great, let's talk about it here, and then let's shoot it over here and talk about some pedagogical aspect. Or I can say, hey, we're talking about questioning this week. Go try it out. How did it go? You know. So this is how we're doing it. And then there's their spring semester they student teach, and they have a seminar that goes with it. It's our third methods course. For the grant, we had 2 objectives. The first is just to get the model off the ground, get our courses together. I didn't anticipate the challenge of connecting these 2 courses because my colleague and I are both very busy people, and all of a sudden we're trying to coordinate common experiences, and that was a challenge. That's very challenging, and we're still working on it. But we're trying to get this model up and running, including developing and refining curricular materials. And then our second objective of our project was to see what impact it's having on our pre-service teachers. And that includes content, knowledge, beliefs, mathematical habits of mind, and knowledge integration. And we are still working on analyzing all this data. And so that's kind of where we are. I want to give you let's see. I'm just going to briefly talk about the 2 courses so that you can kind of see what they're like. It sounds like here you have similar courses where you're talking about content that you're going to be teaching. This one's a capstone course. Basically, it has goals to connect college mathematics with high school mathematics. Another goal is to emphasize problem solving, connections, justification, math communication. It's interesting because it's almost like they're in a lab where they're the students, but at the same time they have the opportunity to stop and think as a teacher what's going on. So my colleague is trying to really model best practices. And so we're trying to understand the math, make some connections. That's our capstone in a nutshell. And our methods course really is, we need to get them ready to student teach. I know that maybe sounds a little bit brief, but that's what we're trying to do. We're learning about pedagogy, we're learning about learners, how do we prepare assessments, what's a good objective, how do we do questioning. We're doing all this, and at the same time we're wanting them in this class to participate in their clinical experience so that they get practice doing it for real. And just so you know, we have on average about 40 students that go through each year. They kind of hit that senior year as a cohort, and they take all the rest of those classes the fall and the spring. So we've had 42 last year go through, and so we have 2 sections of each course, and they're taught in tandem, and they're going through. And when they go out to their clinical, they go out in pairs so that they have someone to work with and to reflect with. So, okay. After 20 years of being in math ed, you think I know, don't put small print on a PowerPoint slide. So I'm just going to help you. This is one of the agendas for my class. Okay, so if it's bad, it's me. I own it. But I wanted to show you how I was trying to make these connections. So in their capstone course, they were looking at unit fractions, and they were trying to categorize unit fractions. Was it simple periodic, delayed periodic, or terminating? And they were trying to come up with a proof. And so I took that activity and I brought it into class, and we had just read Planning for Assessment, the NCTM Mathematics Planning and Assessment Handbook. We had just read that. And so I asked them, answer the 4 guiding questions from Planning for Assessment using the Math 328 activity. So here's an activity you just did. Now, how good is it? So then they did that. Then I asked them about the norms. So Dr. Barker has certain norms in this class. How did they help you achieve the objectives of the activity? And Dr. Barker also had them, towards the end of the class, stand up and do one student from each group stand up and do a micro teaching for the next group over. So they had one person stand up, they rotate. And then the one person was supposed to kind of simulate what you would do to help high school students understand some of this. And so I asked them questions about their little micro lesson and how they felt about it. The reason I could do that is because I was in there observing, which made it helpful. But here, they're having they have an opportunity to go and experience math, hopefully in a way we would like them to teach it. I'm going to vouch for my colleague, Dr. Barker. He's a good teacher. He does a great job. I also admire him because he's brave, because he lays his practice out bare, and he's willing to let us criticize it and critique it. And so, but it's a great experience because students can, will hear things like, oh, when I was doing this, I had this experience. I wonder if that would work as a teacher. So there's one way we did it. Down here in the homework, I tell them, hey, you're going out to the clinical. We need you to be doing an assessment, so talk to your cooperating teacher and make arrangements and get ready to plan this assessment. When are you going to do the assessment? What are you going to be assessing? Again, taking what we're talking about in here and putting it out to the clinical site. I'm going to skip this one, but this one's basically their final was to write a lesson plan on complex numbers, which they had just studied in the Capstone course. So, but again, trying to connect all the different bits of knowledge. One of the things Dr. Barker does in his Capstone course is he tries to have math ed moments. One of the things he did was he said they were getting to a point where they needed to review for an exam. They were going to have a midterm. And so he had his students write a short quiz on the content they had just taught. And he said, include the most important parts of what we've learned. And then he had them switch classes, take the assessment, switch groups and grade it, or take it and grade it, and had them look at it. And he said it was interesting because he was thinking about giving them practice of writing a small quiz. But what he saw was that as they were doing that, they were also going back and looking at their math knowledge saying, what are the important bits? What questions should I ask? What questions don't I need to ask? Wow, I didn't really think that they'd answer it this way. And so now they're thinking about learners. And so that's an example. He always asks, so why did I just do that? He'll have them do something and he'll say, wait, pause. Why did I just do that? And he's asking them, okay, now stop. Think as a teacher, why did Dr. Barker just do that? And how does this connect to what you just talked about in Dr. Winsor's class in the methods course? One of the things that I thought about as I was coming to Georgia is that I had the opportunity to come to the conference to talk about the Situations Project, and I've had the opportunity to look at a lot of them and actually use some of them in my classroom. And I think these are also another way to help pre-service teachers connect their knowledge. And I haven't fleshed this out as much as I wanted to, but I was just thinking, I'm here, I might as well say, hey, yay. Because what does it do? It helps our pre-service teachers, would help our pre-service teachers understand the math deeply. It would help them think about student misconceptions because they come with these situations where the student says this, it might be a misconception, what's going on with that, and then how would we address that? And I have goals of taking these and using them in more detail as we move along in the project. So, wow, I've done a lot of talking. And now here comes all the hard questions, and okay, go ahead.
I'll ask a question. So I noticed that you use NTPA.
Unfortunately, yes.
Yeah, that's right. We're all the same those. I'm just kind of curious how you interface it with your class.
Okay, wow, that's a big question.
So it doesn't just meant to open the water.
Well, no, what we try to do, what we try to do is to, I think there are valuable things in EdTPA that they're trying to get students to do. And so we try to integrate those into the courses. In the next methods course is more of the nuts and bolts. It's like, oh, so you have to videotape yourself, or oh, you have to write about this, or oh, you don't understand this rubric. But in the first two courses, we're trying more to connect with the practices that they're promoting and focusing more on student learning and student outcomes. So and we've been working on it this is our 4th year, because Illinois is all fired up, and next year it goes live and we're scared as heck. But we've tried to take the parts that we think match up with what our goals in the courses and kind of infuse them in. Yes?
It's Dr. Winsor. Let's say that magically you could add 5 weeks to your course. What would you want to add?
What would I want
You've
to
talked
add?
about what you do, yeah.
What would I want to add? Gosh. Did you warn me that you were going to ask a question like this? You know, I think one of the things I would really love to do, because I feel like in a methods course, we have this much knowledge to try and fit into this much space. But one of the things that I think would be really important to do is, if I put that 5 weeks at the end, I would take those 5 weeks and say, okay, we've thought about a lot of things. Let's start planning to use those in your student teaching. So we talked about homework, we've talked about creating assessments a little bit, right? Haven't we had that discussion? Now let's start starting to craft a plan so that when they went to student teaching, they would have sort of a foundation to stand on. One thing I find is that pre-service teachers get to their student teaching site and they're excited and they're green and they've got energy and they're fired up. And then the cooperating teacher says, so what do you want to do? And they go, I don't know. And the cooperating teacher says, here's me. That's what you're going to do. And because the pre-service teacher hasn't had the opportunity to really try and make some initial decisions, they just kind of say, okay, and they take it. I don't know if I'd use that whole 5 weeks, it would be nice. I'd work with assessment, I'd do a lot more on assessment too. But it would help them start to make teacher decisions. That's one of the things I try to do all the time. We're talking about this and I say, this thing might not work for you based on your personality or your students that you have or the school that you're at. You need to make these hard decisions. Are you going to try it and see how it works or not? So, I don't know if that helps. Yes?
So you're really developing a model of
Trying
teacher
to.
education.
Yes.
And could you share with us some of your data design, the research design for testing the model?
Okay, so
It sounds like you have a lot of data.
right now we are kind of we're kind of like right up here in data, and
Okay.
we did some surveys. John Dossie was helping us with some belief surveys and some of those sorts of things, and that was all. We didn't change their beliefs, but right now what we're doing is we're going through field
You
notes.
didn't see any change pre-post of beliefs?
No, John said, John's very supportive though. He's working with us to
Over like one semester?
we did it over a year.
Over a year?
Well, we did it we saw some changes from beginning of the semester to the end of the semester we were teaching in, but then we took another one after when they had been away from us for a semester, and it kind of all just slid back. And part of me felt like, well, I wasn't really trying to change their beliefs. I mean, I guess I was in a sense, But my purpose wasn't to say, you believe this, I want you to believe this. My purpose was to say, I've got this model, I'm going to try it, and I'm going to try and see if the things I'm doing seems to give them opportunities to use these different types of knowledge in tandem. And so where we're really focusing on right now is the field notes and and a couple of scenarios that we gave them, where we said a student comes and says this to you about this bit of mathematics. How would you respond to him? What kind of intervention might you do with them? You know, those sorts of things. So we're right now looking at that because we're hoping that to see that, you know, we implemented this in class, and all of a sudden in the discussions they're starting to pull from different places things that they know to talk about what we're doing. So they might talk about, in my clinical I did this, in methods course we talked about this, when I was studying, you know, when I was thinking about this bit of mathematics I was doing this. And so we're trying to find those things, and we're doing that through our field notes right now, and we're still very much buried in our field notes because coding them has been it's been challenging for us. I don't know, I've heard that everyone else has easy times coding, but we argue a lot, and it's interesting. I've never argued with a friend of mine as much as I have with David Barker. When we sit down to talk about coding and what we've been doing, we get after it. So that's the challenge. We're still not quite done yet, and so I'm always hesitant to say, and we found this. We have noticed there are some times when just initially, like for example in Dave's math capstone course, where he'll ask, so how might a student think about this? And all of a sudden the discussions go towards, well, when I was working with at my clinical site, this happened, and in methods we talked about this, or we read this article, so this must be true. And so there's certain things that we're seeing that at least seems to kind of hit the buttons for all those different types of knowledge, but we're still nervous to say anything. Unfortunately, we're working on it, and hopefully we're hoping to have a lot more to say, because just on a personal level, I've seen a lot of cool things happen where they're talking and all of a sudden they're like, in my methods course, they'll say, Dr. Barker did this when he was teaching, and my cooperating teacher did this when he or she was teaching, and this is connected to what I was, and we just read this and hum. And I'm seeing that perhaps, and I don't know, but perhaps, just perhaps they're making connections, because I don't know, because I can't get into their brain. I don't know how to do that yet. I wish I did.
So one thing I thought was maybe implicit in your presentation was that maybe some of this work would help students have more positive experiences than maybe you did when you were first. Did
I sound that bad?
Well, yeah, or at least reduce some of that. And I was wondering if you would just elaborate a bit on how you felt it might do that, if you were implying that.
So if I were implying that, I think, well, there's kind of two things. One, what we're doing right now, okay, let me back up. We'll go to my experience. When I took my methods course, it was a very bare methods course. It was a methods course for the history teachers and the English teachers and the social study teachers and the science teachers and the math teachers. Okay, so everybody. And I would go in there and I would sit down and they would give me an awesome example from history. And I would immediately go, bam! They're like, oh gosh, Matt, what? Yeah, how does that work in math? And they're like, well, you're a math teacher, you'll figure it out. Go ask your professor, which one? I didn't, I had math professors, I had education professors, there were not math educators. I guess ones that I could say, yep, that's a math educator. There are professors that I could go and talk to, but you know what I mean? And so here now they have a methods course and a content course where we're trying to connect it to the high school class. We're trying to help them see, okay, I'm studying this because, and this is how it's connected to this, and this is, and when you try this out here, you can come back and ask more questions. You know, I didn't have a practicum either. I didn't have a clinical site. So once when I went out to student teach, I had taught 2 lessons. Our kids, when they go out to student teach, they've implemented at least 5 activities, and they've team taught for 5 days. So in addition to the activities, so they've had more opportunities to practice. And so I think that opportunity to practice and that opportunity to try and make connections. And when I'm teaching the methods course, I just like to tell them the punchline, like, look, you guys have an awesome experience to sit in a course with a professor who knows about teaching math, who studies it, and who's willing to let you criticize his teaching, and who's willing to talk to you about it. I never had that. Even my cooperating teacher wouldn't really tell me what they were doing or why. And that was in student teaching. So now we're trying to, at least at ISU, we're trying to give our students that opportunity and make it not so bad. Now,
So in this sequence of courses, it seems like you're really trying to foster connections between them. But they're still kind of under your control when they go out to student teaching.
yeah.
So how are you trying to continue them making those connections from the content of the courses, your pedagogy, then they have this really rich field experience? What are you guys doing trying to engender?
So you mean next steps?
The next step or the next course when they go out to student teaching?
That's a great question. And ideally, I like to say it's all perfect, but we haven't got, it's kind of like we haven't got there yet. But that being said, we do have the seminar that goes with the student teaching, so spring semester, senior year, where they come back. We are still, in addition to helping them with that TPA and some of the nuts and bolts of trying to get out of the university, we do have people come back and are still trying to work with them and connect to their classroom and give them presentations that are applicable to the classroom. And I think, so, but what's interesting, and we chatted about this earlier, is it seems like we need to get, I want to do that.
Yeah.
But what we need to do is get a grant for that to help promote that, and someone needs to write that, and someone needs to do that. Assuming that all this works, we try. But it's interesting because we send our student teachers that we keep some of them in Central Illinois, but we send a lot of them out to Chicago. And so there's not a lot of the close proximity that you would like. They're out there, and we have university supervisors who are retired and are very active in the Metropolitan Mathematics Club, which, by the way, is a precursor to NCTM. For those of you guys who don't know, Math Ed Jeopardy for 500. But there are university supervisors, and they go out and help, but we still don't have that kind of connection. Dave and I have always said, well, if we were insane and had about 85 more hours in the day, we'd love to come to the seminars and get groups and just have discussions about those kinds of things, how they're connecting, after they've had their gripe session. So I did not know that teaching people how to be high school teachers was such a challenge when I started trying to do this. I think I should have been maybe a mechanic or something. But I'm here now and I'm happy and I'm glad I am. And I'd have been a horrible mechanic anyway because I can't fix a darn thing. What other questions? Yes.
I guess this is kind of a statement and a question. First of all, to give you background, I'm coming from a middle school science perspective. And I really resonate with a couple of things you're saying because number one, we also, in our middle school science teacher preparation program, have paired content and methods courses. And the people who teach the two communicating with each other and trying to build on each other. It happens that Ryan in the front row was teaching the content course, and I was teaching the methods course last spring. And one thing, I kind of had the same exhilarating yet frustrating experience you had with, you said at one point, personally, I see all these neat things going on here and there. On the other hand, you did a pre-post and
Yeah,
there wasn't any pre-post. I didn't actually do a pre-post last spring, but I have a feeling if I did, we wouldn't have seen anything statistically significant.
Yeah.
And, but I would just encourage you to keep this up, trying to do the paired content methods courses, because there were so many times when, Ryan, you can remember several times when you were teaching, I was sitting in the back of the room, I was just getting so excited about what you were doing. And I just couldn't wait for, it was going to be 2 days later when I was going to be able to follow up extensively with the students and say, remember what Ryan was doing?
Yeah.
Well, you can do that with middle school kids. And sometimes it works really well, but sometimes it's frustrating.
Yeah, I've had that when I would sit in Dave's class and he was doing something. I'm like, what's the matter, Dr. Winsor? The Dodgers won. I don't know. Hold on. But I was excited because I knew that the very next day, because he did Monday, Wednesday, I did Tuesday, Thursday. I knew the very next day we were going to get in and talk about it.
Well,
And, yeah, so I agree.
And sort of the question I had that I wanted you to elaborate on is, I gather that you're in, if I understand correctly, this is an enviable position, where your students are actually able to think about and apply ideas that you give them about assessment in their practicum.
Mhm.
Because I've always included a lot about assessment, and tried to get my students thinking deeply and seriously about assessment in my methods courses. On the other hand, it's frustrating because when they get to their practicum, which sometimes is concurrent with my course and sometimes, anyway, that's the one thing they have zero latitude in practice. Typically in their practicum classroom, the general message they get from their cooperating teacher is, you can try to achieve these goals any way you want, but here's the way the kids are going to be assessed. No discussion. So can you give me some examples of how your students actually were able to critically and creatively develop assessments, whatever kind that they actually used in their practicum?
So I should precursor this by saying that we work really hard with our cooperating teachers to make nice. We want them to have a good experience. We ask for their feedback. We ask for their input. If I could take them all the tacos, I would. But they come in when we get them, and a lot of them have worked with us for a while, so they know what we're doing. But when we get new cooperating teachers, we send them we send them in short, manageable notes that say, hey, we want kids to try stuff in here. And yeah, you're in charge, but Dr. Winsor, who's big and ugly, is going to be assigning these things, so please let them do that. And I always go out and meet with the folks, and we have a coordinator who goes out and meets with the folks, and we try to keep it small at first, implement a task, which might be, here's a word problem that they're going to try, or here's a pattern that they're going to try and discover, just whatever. Maybe it's a warm-up, So it's not going to take a lot of the teacher's time, but the student's going to be able to put that task up, see how the kids do, and then come back and reflect on that. And so we work up to a quiz. So we start small, task, quiz, and then we ask the teacher to let them co-write an exam for the stuff that they're teaching for the 5 days. I know, we're bold.
Many of our cooperating teachers don't even have input into the summative assessment.
Yeah, we
Not much less our interns.
And I understand. I lived in Texas for 6 years. I understand that very well. We are lucky that way. And I'm not saying that it works perfectly, because I still have teachers that they're going to do it my way. Here's my exam, and my students will come back, he gave me his exam. I'm like, well, I'll tell you what. And I say, so, okay. You look at that exam and you decide, is it good? Are these problems good? You can come tell me about it, even though, and then when you grade it, tell me what happened. Did it assess the objectives you had? So we still try to massage it so that they're having some sort of experience where they're having to make the decisions. So even if they didn't write it, which happens, they've still thought about it, they still graded it, they've still decided what do students know, and has it informed them about students' knowledge of the objectives that they had for that lesson or that.
And it sounds like you're actually encouraging them to put a lot of thought and a lot of formalization into formative assessments.
Yes. Yes,
Because maybe they don't have that control, or maybe even their.
I have a t-shirt that
teachers don't
says
have that
formative
control over
assessment. I
summative
wear it
assessments.
every time that I
Okay.
teach because they need, we keep talking about, so what did your students learn today?
Mhm.
What did they come away with? Well, I taught this. No, I know what you taught.
Right.
What did you learn? So.
Well,
Thanks.
Thank you all so much. If you have any more questions, you're welcome to talk to him. He's a friendly guy.
So far.
He will not bite you.
There, you can email me too.
So please join me in giving him a round of applause.